This example actually summarizes the entire chapter. So if you know this, then you're fine. So we're going to spend a maximum of $9,000 to buy X round tables and Y square tables. And we need at least 2 round tables and 5 square tables. And in addition, the number of round tables should not be less than a quarter of the number of square tables, okay? So the cost of each round table is $1,000 and each square table costs $750. If each round table has 10 seats and each square table has 4 seats, how many tables of each type should be bought to maximize the seating capacity? Okay, so this is a very practical example that we use linear programming. So in step 1, we need to write down all the constraints on X and Y. Okay, but that has to be a separate thing compared to our goal. Okay, so if you look at this part talks about the constraints, and this part is actually our goal. What are some of the constraints? The first one, total spending is $9,000. So using this information, $1,000 for each round table and $750 for each square table, and our total spending has to be less than or equal to $9,000. That's one of the constraints. What's another one? At least 2 round tables and 5 square tables are required, and therefore X is greater than or equal to 2 and Y is greater than or equal to 5, right? What else? Round tables must not be less than a quarter of square tables. And so X must be greater than or equal to Y over 4, right? But that's not all the constraints. X and Y has to be integers. Moreover, cannot be negative numbers, right? And so altogether, these 5 are the constraints. Okay, now these 2 lines have numbers, okay, but those are our objectives. Okay, so they have to be separate from what we use for the constraints. So after you've simplified the inequalities, you get these. So that is the end of step 1. Now step 2 is to put all these 5 things onto the graph. Now for this one, X equals to or greater than 2. This line points to the right because it's greater than or equal, right? Now the second one is Y greater than or equal to 5. That is this line because it's greater, right? So we point upward. Now for the third one, we first draw 4x minus y equals to 0. That's this line. We're going to use 0, 0. But unfortunately, 0, 0 lies right on the line, so we cannot use that one. So we could pick, say, 1,000, 0. Okay, if it's 1,000, 0, that would be 4,000, right? And obviously, yes, it's greater than 0. Okay, so we point it to this part, right? Or if you want to use 0, 1,000, that is somewhere on this side, right? So 0, 1,000 would be negative 1,000 here, and that is wrong, right, for this inequality. And we will choose the opposite, okay? And for the fourth one, we draw this line, 4x plus 3y equals 36. And this time we could use 0, 0 and put it right here, and that gives us less than. So this is good. So this part of the world is good, so we point it to this way, right? So when we put all of these together, this gives us the region for all the feasible solutions. However, in this specifically, x and y have to be non-zero integers because we cannot buy 4.5 square tables, right? Only these dots could be the answers, could be possible. So we have to write this statement here when you do your homework. Now let's go back a little bit. When we were drawing these lines, it seems that it would take a lot of time, right? For especially these two. But just a reminder, if you consider the x and y intercepts, then you will automatically get 2 points and then you just connect them to get a full straight line, right? So that will save you a lot of time instead of making up some numbers for x. Whenever y equals to something, that would be a horizontal line, and whenever x equals something, it would be a vertical line. okay? And greater will be on the right hand side or the upward. Now finally, we can look at our objectives, and we will try to find the maximum seating capacity, right? So if each round table has 10 seats and each square has 4 seats, how many seats do we have? So we let C to be the seating capacity, and of course C equals to 10x plus 4y. So draw the straight line of this on a graph. So if you still remember, you just keep the x and y term and everything else to be 0, and we want to graph that one for our objective. And that would be this yellow line here. Now think about this. If I keep this slope and I keep pushing this objective line outward, okay, your x and y would increase, right? Then you could tell the C would increase as well. Okay, so the farther you go, your C would be greater, right? So when the line gets here, it touches the lowest point, this would be the lowest of C, right? This would be the highest of C. Then we write from the graph, C attains its maximum at the point 5, 5, right? This is the farthest one. Not this one, not this one, but this one. Okay, and so the maximum of C is we put 5 into the formula to get the highest C. And so we have to buy 5 round tables and 5 square tables in order to maximize the seating capacity, and it would be 70 persons.